Hi and welcome to another chemistry lesson. We are looking at organic chemistry, and in this one we're looking at naming alkenes. Okay, so far we've been looking at the alkanes, and we knew that alkanes, or how we would know something is an alkane, is that there is only carbon and hydrogens. There are only carbons and hydrogens called hydrocarbons, and every carbon has the maximum number of hydrogens. So let me give you an example. Okay, so a carbon is singly bonded to another carbon, and all of its other bonds are saturated. It's completely filled up with hydrogens. Okay, this is called a saturated hydrocarbon. Okay, and these are called alkanes. Now, alkenes are similar. The only difference is that alkenes have at least one double carbon bond. Okay, so let me give you an example. The simplest of the alkenes are when we have a carbon double bonded to another carbon, and that's it. So notice when the carbon is double bonded to another carbon, it means that this first carbon is sharing two of his valence electrons with two valence electrons from another carbon, and which means that he's got two valence electrons left, which he would share with a hydrogen, and this one will do exactly the same. So this is the simplest alkene that we can get. Now, naming works exactly the same. So if we were to let's start with the condensed structural formula. Condensed structural formula would be describing each carbon and the hydrogens, or all the bonds that they have. So we'll start with carbon, then we do the hydrogens. The first carbon has two hydrogens. The next carbon has two hydrogens. So this is the condensed structural formula for, and now the name. This is methane. So, no, I lied. Ethene. Ethene. Now, another common name for this is ethylene. Ethylene, okay, but don't worry too much about it. The UPAC name that we are going to use, the UIPAC name, that we are going to use is ethene. So, how will we do the naming for alkenes? Is they will get the suffix at the end, where we had suffix ane, A-N-E, for alkanes. This one will just get the suffix E-N-E, alkene. The rest is exactly the same. For a single carbon, we would have used meth, but obviously you can't have a single carbon double bonded to another carbon. That won't be a single carbon chain. So the smallest one is ethene. The next one would be if I have three carbons. The first one double bonded to the next one, single bonded to that one. Okay, so this one has two valence electrons left. Okay, there's at least one double bond, so it is possible to have two double bonds. Okay, I'll give you that one's name in a second. Just notice now the middle carbon. This middle carbon has 1, 2, 3 of his valence electrons left, so he's got 2, 4, 6 in total, which means we need one more to be shared with hydrogen. And this one here on the end only has 2 valence electrons. Remember, the stripe represents 2, so we need a total of 8, so we need 6 more. So this one is saturated. This carbon is saturated. Okay, as you can see, these carbons are unsaturated. These are unsaturated hydrocarbons. What we mean by that is they don't have the maximum number of hydrogens they could have. This one on the end could have 3. This one is on the end, he could have 3. This one here in the middle carbons can have at least 2. Okay, or well, middle carbons can have 2. And this one only has 1. So and this one could have 3. But he has only 2, so they are unsaturated. Okay, condensed structural formula for this one is carbon. The first carbon has 2 hydrogens. the next carbon has 1 hydrogen, and then the next carbon has 3 hydrogens. Okay, this one is called propene. Propene. Okay, now let me do it slightly more complicated, okay, by just adding 2 double bonds here. So we've got a double carbon double bonded to a carbon double bonded to another carbon. Okay, so this one has 2, and I'm going to ignore the hydrogens for now to save some time. So we've got a carbon double bonded to another carbon double bonded to another carbon. You can see this middle carbon doesn't have any hydrogens because he's already got 4 valence electrons occupied. Okay, so this one's condensed structural formula is CH2, CH2. Okay, and what is his name? Okay, this one is called propene. Now, this would be an acceptable name because that is applying the rules, but because it pronounces slightly odd, it's rather pronounced as propadiene with an A there. But you notice what we did. The moment that we had 2 double bonds, we had to indicate that we have 2 double bonds. We can't just now call this propene because propene has 1 double bond. The moment we have 2, we include the di, which represents 2. Diene means 2 ene bonds, which is the double carbon bonds. Okay, now this is still fairly simple. Let me just show you what is going to happen the moment I go one more carbon. In other words, here I've got 4 carbons. We know that this one is going to be butene. Okay, butene. That's simple enough. But what if my carbon now happens in the middle? Or let's go back to this one. This one, even if I were to draw it in this direction, okay, in other words, my carbons are, sorry, that one should just get 1. My double bond is at the end. Well, it's just this one turned around. It's not now any different. It's just this one looked at from the other side. So this is the same 2 molecules. But this molecule, okay, is different from this molecule. Okay. Notice I still have only a single double bond, but this time my single double bond is between the second and the third carbon, while this one is between the first and the second carbon. So usually, technically this one could have been but-1-ene, okay? And the reason why we would have done this is to tell the reader or the person that's studying this that your double bond is between the first and obviously then the second carbon. In this case, this one is still but-2-ene. And that will tell us that the double bond is between the second and the next one, which is the third one. Okay, so in a longer chain, in this case, it wouldn't matter whether I number from the front, or if I number from the back. Okay, you would see that the first, I wouldn't call this one but-3-ene, because but-3-ene would have meant that it's between the third and the fourth one. And if it was here instead of there, in other words, if this one, let's wipe this out, if this one wasn't there, that one wasn't there, this is actually just but-1-ene, because again, it is making a double bond with the first one. So we will number from the closest side where we have the double bond. So if I go one more, Okay, so let's say we have a carbon here, we have a double bond here, and then we have another carbon here. So here we have, okay, just a rough sketch of that. Okay, so we've got 5. That means we're working with paint. There's at least one double bond, which makes it an ene, but the double bond, and now I can either number 1, 2, 3, 4, 5. So this could be pent 3-ene, but that would not be correct because the closest carbon to one of the ends is the second carbon. So I should rather number from the back. So 1, 2, 3, 4, 5. So this would be one pent 2-ene. Pent 2-ene. That is pent 2-ene. Okay, and the rest are filled up with hydrogens. So what will happen if we were to add a branch to this main chain? So let's say here we had another branch. We had a normal 2 carbon branch. This, remember, is called an alkyl. Alkyl is an alkane substituent, a branch that looks like an alkane, single bonds. What will happen to the numbering? Because in the previous video we looked at we should number starting at the carbon that's closest to the chain. Okay? Now we said we should number starting at the carbon that's closer to the double bond. In this case, we will the double bond will get preference. So your functional group gets preference when it comes to numbering the carbon chain. So this specific one would still be called pent 2-ene, and now we just need to indicate that there is an alkyl substituent, which a double carbon would be an ethyl, and now it's important, where would we encounter this ethyl, on which number carbon? Okay, remember we are numbering so that the ethene comes, sorry, the double bond comes first. So we have 1, 2, and that's where we encounter the double bond, 3, 4, and now we encounter the branch. Okay, so the branch is 4-ethyl pentene, and this is the UIPAC name for the structure you see in front of you. So basically it works exactly the same. The only things that you need to understand that gets added here is the suffix, that is an ene at the end when there's a double bond. Okay, then that ene could likely have a suffix, a prefix itself, depending on how many double bonds there are, and it can be di, tri, tetra, etc. And then the only other thing was when it comes to numbering the carbon chain, it's not the branch that gets preeminence that we should encounter it first, but rather when we number we should encounter the double bond first. And that's it from me for this lesson. It's not very difficult. I hope you enjoyed it and you learned something, and I'll see you in the next video where we'll look at probably at the alkene reactions. There's quite a few of them since we can now look at both alkenes and their relationship with the alkanes. So I'll see you in those videos.